Um, Welcome, and thank you all for coming and for helping Gallo and I celebrate the launch of our book, Homing the Machine in Architecture. Um, Also, thank you to Cooper Union for hosting the event, for letting us host the event. Um, for those that don't know me, which I think is not that many people here, but in case you don't know me, I'm Zach Cohen. I'm an adjunct assistant professor here. I teach robotic fabrication courses since the book. Um, so the way tonight's going to work is we'll give a little, Gal and I will give a little intro to the book, what it's about, and then we will invite three of the book contributors that are here to give brief talks about their work and their contributions to the book, and then we will have a panel discussion with them, myself, Gallo, and the contributors who you'll meet momentarily. So to start, we wanted to set the stage for my discussion by briefly explaining the book's sort of organizing metaphor, which is also its title, Homing the Machine, along with some of the book's aims and motivations. So to home a digital fabrication machine is to determine its origin point, the point in space at which the machine begins making. And homing is necessarily the first step in every digital fabrication process, since it provides the machine with addressable spatial coordinates that will serve as a reference for all subsequent coordinates that will visit along its toolpath. So when we typically create a digital fabrication program, we either specify our own origin points or use default origins that are pre-programmed into the machine. If we decide to specify our own, we often do so in consideration of the thing we are digitally fabricating, for instance, its size or fragility. So each time we digitally fabricate something different, we may decide to change the digital fabrication machine's origin. And in this way, origin points demonstrate how what we decide to digitally fabricate is intertwined with how we decide to digitally fabricate, suggesting that physical origins always in some way follow conceptual ones. Since digital fabrication's introduction to the field of architecture, architects conceptualized various things for digital fabrication machines to make. And this applied research has resulted in a variety of different approaches and ideologies, as well as many different origin points. They're a kind of cross-section of the work that's been produced over the past 25 years or so. And yet the discourse of digital fabrication and architecture has generally remained centered on the technically oriented rhetoric inherent to digital fabrication's industrial origins. Buzzwords like streamlining and optimization still abound, and there's more often discussion on tools and techniques rather than virtues and values. So here, if we look at the recent themes from the biggest digital fabrication conferences in architecture across the world, we can infer the ways in which digital fabrication is most often discussed. So starting from the left here, this is from ICADI from a few years ago, the ICADI conference. It's Architecture in the Age of Industrial Revolution, suggesting, or Fourth Industrial Revolution, suggesting that, the digital fabrication's roots are, or implying that digital fabrication's roots are from the digital revolution, which is correct, but also that we're kind of stuck still in that industrial paradigm and have not moved beyond it. The ICADI conference in 2023, entitled Accelerated Landscapes, implies that we have this sort of fixation on doing things faster, always bigger, always better, potentially, or that those things equate to being better. And then Kadria 24, still trying to go faster, right? Still accelerating. So there's this constant fixation on speed, on efficiency, on arguably on what we argue to be sort of neoliberal values, rather than the sort of conceptual values that may drive architectural practice. And then most recently, Rob from this year is Beyond Optimization, which sort of implies, that we are, or sort of infers that we are still stuck in this kind of idea or this fixation on optimization, and that we are in the process of working beyond it. But if you look at the conference proceedings from that Rob, I would argue that we are still very much stuck in this idea of optimization, which goes along with acceleration, speed, efficiency, and stuff like that. And so it's this kind of friction between the persistently technical nature of this type of research and the undeniably conceptual nature of architectural design that's made it difficult to locate digital fabrication's origins, or homes, as we call them, within the greater discipline of architecture. But given the amount of subjectivity in the acts of digital fabrication, from homing the machine to realizing digital fabricated assemblies, we felt it was time to look into the decision-making processes behind the more often discussed technical details. And so in this book, we fundamentally ask two questions. First is, what are the conceptual origins from which our physical origins emerge? And the second is, how have these conceptual origins informed the kinds of things architects and designers have decided to digitally fabricate? I'll now pass it off to my co-editor, Galo Canizares.
Thanks, Hi, everyone. I'm Galo. I'm the co-editor of Homing the Machine in Architecture. For those of you that don't know me, I'm an assistant professor at the University of Kentucky. And so when thinking about the structure of this book and how it might be organized, we decided to use the metaphor of origin in a couple of different ways. One, as the point at which something begins or rises, or maybe even from where it's been derived. And then also thinking about parentage, genealogy, ancestry, right? But we were thinking about histories of architecture, and we really wanted to break away from these, let's say, grand narratives. And so we took a cue from the late Tony Vidler, who in Histories of the Immediate Present talks about how, for example, the history of modernism is often used as is often crafted in a very specific way to legitimize the practices that the historians are interested in kind of propping up. And so in architectural history, you see these kind of dominant narratives and the discussions on very specific sites of discourse, which in turn, basically reinforce power dynamics. And so what we wanted to do is talk about multiple origins instead of just singular origins. We wanted to talk about multiple genealogies, multiple parentages, and bring them all together in this volume so as to maybe arrive at produce different lines or trajectories that maybe all converge and also diverge in different ways. And so we took the concept from Carlo Ginzburg as well of microhistory, where we could actually narrow in on very specific individual histories. And those individual histories actually don't necessarily make up a grand narrative, but they actually tell maybe a broader story of how a discipline or a field can emerge. And more importantly, actually, the concept of microhistory and the idea of having multiple histories coexist at the same time allows us to sort of break up some of those power dynamics that have existed in architectural history. And so the book itself is structured in around three perspectives: the technological, the material, and the social. Now, the technological is probably the one that you're all most familiar with if you've been in digital fabrication classes or just, seeing the kind of things that architects kind of make with digital fabrication tools, right? Everything's about using robots, highlighting the latest technology, et cetera. But we also wanted to highlight the material perspective as well, because that's also becoming increasingly important with material research. The conferences that Zach showed, those are always interested in showcasing new advancements in material development, construction materials, even sustainable materials, et cetera. And also maybe even biomorphic materials, right? That's the kind of latest thing. But the social is probably something that is the most under-discussed. And so we really wanted to put an emphasis on the social in this book as well. And so we invited people from the industry, from practitioners from the Global South, to talk about what does it mean to practice digital fabrication in a kind of social sphere, or what are the social dimensions of digital fabrication, whether it's the politics of the Fab Lab or the transmission of knowledge from the global north to the global south, and all of the kind of politics that are that come with those issues. And so today we're going to hear from some of the contributors to the book, and really what the broad question that we're trying to answer is, what is a critical digital fabrication, or maybe what can be a critical approach to digital fabrication? And so this is kind of a kind of cliche toward a critical digital fabrication. But with this, I'd like to introduce our guest panelists, who are going to give some brief overviews of their contribution to the book, and then we'll have a kind of roundtable discussion. First, I'd like to introduce Mike Szivos. Mike is the founder of SoftLab, a New York City-based design studio that combines research, technology, and ideas to craft work that spans multiple mediums and scales. SoftLab was awarded the Architecture League Prize in 2012. Mike also teaches at Pratt University and Yale University. Marshall Prado is an assistant professor of design and structural technology at the University of Tennessee. Marshall has previously taught at the University of Stuttgart in the Institute for Computational Design and Construction, the University of Hawaii, and University of Michigan, as well as Carnegie Mellon University. His current research interests include integrated computational design, robotic fabrication, additive manufacturing, lightweight fiber composite systems, and lightweight composite systems for architectural applications. Shelby Doyle is a registered architect and associate professor of architecture, where she is the Stan G. Thurston Professor of Design Build at Iowa State University College of Design and co-founder of the ISU Computation and Construction Lab. The lab that Shelby runs is the result of Doyle's ISU Presidential Impact Hire to rethink digital fabrication and design build. And so I'll leave it up to you to decide in what category our guests belong to. But with that, I'd like to invite Mike up. Thanks, Mike.
Thanks. Yes. Thanks, Zach and Galo. So I guess I'm going to talk a bit about, my approach to our contribution to the book. I think it's, it's really interesting for me when Zach and Gallo asked for a contribution. I think, and I'll talk a bit today about some of the work previous to the contribution, but I think just generally, when I was an undergrad, I kind of took, like, history for me was something that I put in a loose category of things that were, I think, called boring. So it was something that I didn't really look at. Everything was, like, really new. And then, of course, I don't feel that way anymore, but also it's a very naive thing because ultimately you have to deal with your own history at some point. So I just think it's kind of young person thing. So I think when they asked me, especially in the context of homing the machine, I think I decided to deal with that history. So the office has been around for, let's say, 15 years, and we've kind of like stumbled through some of our projects, and that's how we've learned. But I think in terms of homing the machine, I think it's like, it could be about calibrating or in many ways, like, let's say you're off track. So in thinking about this, I thought that those points or moments where we were off track were maybe good things. And so how do we leverage those things throughout the office? So a bit what I'll talk about is like my pre-SoftLab brain, and then how it kind of led to SoftLab. So I moved to the city in 2000 after undergrad, and so I think I had this romantic view that I would somewhere exist between these two versions of the spectrum in terms of architecture. So the romantic left, or the kind of like prototypical architect. I think the romantic left hasn't really changed that much. I mean, everyone on Lower East Side looks like that. Architecture has kind of changed a bit, but somewhere in between here, I knew I couldn't be as cool as people on the left. And so I worked in an office. My main goal one of my reasons for coming to New York was to go to grad school at Columbia at GSAT. But I decided to work in an office first just to get my bearings. So that summer was the first DS1 warm-up, and shop created what was called the Dunescape. And so I think we went every other weekend. It was super fun. It was also a time when I guess I realized architecture could just take other venues. Like, I was very much about making buildings when I moved here, but seeing architecture in this venue, where it's basically like the backdrop for a party, I think started to, let's say, germinate different ideas in me or my brain in ways in terms of the work that we do today. There was also parties in Anchorage, in the Brooklyn Bridge, Anchorage, called Art in Anchorage, that were put on by Creative Times, which are pretty amazing. In the really raw space of the base of the Brooklyn Bridge on the Brooklyn side. in Dumbo, and in that raw space, they commissioned art, I guess, light installation. So it was also the first time I had ever seen, let's say, a large-scale site-specific interactive installation. They also had like parties, drum and bass parties, hip-hop parties. So this was also super fun, and another venue where I think architecture or spatial definition took on a different role than what I thought of as building. So New York turned out to be great. So then I started my plan to go to apply to Columbia or GSAP. And then in September 2000, after that summer, this issue of Architecture magazine came out. And so I said, oh no, is this a school I really want to go to? It's funny today to talk about Columbia as a blob school because people even say, well, what do you mean? And it was so pervasive then that, everyone say, oh, that's just a blob school. They don't know how to build anything. This was the later years of Shumi's time at Columbia. And so for me, looking at the work in the 90s, it seemed like the most experimental school to go to at the time. But as you can see with this image, also I was very interested in making things. So, with this image, the kind of tectonics of this quote unquote house is reduced to is reduced to a texture map. So not only this cover, but also inside the magazine, this is Shumi straddling two stools, and this is the faculty. So in between that first image that I showed, what emerged is this kind of like, in my mind, the kind of rock star architect, or the kind of, and a lot of these guys have pioneered certain digital tools, but it was very much about being very cool, and in many ways what I thought was esoteric. So I questioned, should I go to a school like this? I thought about going to school in Europe. I applied to some schools in Europe. And at the end of the day, I decided to go to Columbia. I went back and I came back. I also had fallen in love with New York, so I had a great time there, and I learned tons. But the response to those guys was something like this. I think this is the approach we took with the studio in the beginning, which was, instead of the kind of esoteric, like, expertise in digital technology, we were kind of like, we have absolutely no idea what we're doing. This is the look we would give people, and this is the look we would hope to get back. So a lot of what we did was really thinking about how we make things rather than how we talk about things. So rather than talking about things, we wanted to show people the things that we made. So I think, and this is a slide I used to show in the early days of the studio, if I spoke anywhere, but I think even to this day, most of the work you'll see on our website, it's not renderings, it's not proposals, it's the work that we made. Regardless of the tools that we used, it's really about like showing what can be done instead of talking about what can be done, which also happened a lot when I was at GSAP. But also while I was there was a course called Algorithmic Architecture, which was taught by Corey Clark, and this was something. It was something new. It wasn't something I'd heard of before. I also have a background in high school. I went to engineering high school, so I had like 4 years of programming, which I had not used at all in undergrad architecture. So I said, well, I'll take this course. This sounds interesting, and see what it's about. And most of the assignments that we did, or the exercises that we did, were really about, using, let's say, scripting tools that made like formal arrangements of shapes, so spheres and things like that. But one of the assignments that Corey handed out had this posted on it. It was this was the photo posted, but it said something like, a table with a depth and a width, and as you change the depth and width, the number of legs changed based on those dimensions. I think the word parametric was used then. I don't know if it was used, but this was something that I had not heard of. This posted, like, it totally blew my mind that you could strip something that would have a kind of intelligence to it. So while this is something that's pervasive today, this was about 20 years ago. This was something I had not heard of. But this was something that really became interesting to me, less than the kind of the formal stuff. And so we had to do a final assignment for the course. And I asked Corey, what should I do? And I think Corey was relatively excited that someone in the course had a history in programming. And he said, why don't you make a tool that makes something? So also at that time at Columbia, there was a ton of these kind of waffle mount models, which was the only way to really build those kind of blob shapes, which were on the cover of Architecture magazine. So everyone would painstakingly make the drawings for these models. There was no Rhino. There was no Rhino slice. They would slice the models, and they would place notches in the models. And some of the studios, these were the only models that were made. So kind of as a joke, I decided to make a tool that allowed people to automate the making of those drawings. And this is using Maya, which is an animation software that we were using a lot at Columbia at the time, but also has a pretty open-ended interface that you can customize, which is why, let's say, movie studios use it. And so this is a custom tool built. I'm sorry about the resolution. This is so old. I couldn't find anything better resolution, but I figured I would keep this one. This is the original because it even has that kind of DOS shell Windows kind of interface still. But you can see, so it generates the slices and the notches. So this is something like, that Corey asked me to present this at the show where we basically, at the time, Columbia was a big animation school. So we would do the screening of the animations, which was quite fun, but he asked me to showcase or show this at the screening. So everyone thought this class was a joke. But then when I showed this, I mean, I think everyone started clapping. Everyone was like screaming, "Can I have that? Can I use that?" Basically to build those models. So I think it was the kind of beginning of developing those tools for me at least. And this is just the final model for that class, which is like a concept. So from there, because I became the scripting guy, a group of students formed an independent study in the school, students I didn't know. And so they wanted to automate the production of, let's say, a complex surface. And to do that, one idea, or the idea that everyone had, was to make articulated connections with that surface, so to get rid of the frame. So if you want to make a complex surface, as naive as we were, we thought it was really about the frame, which also, at the end of the day, of course, structural. But so they needed someone who could write the code to automate this process. So through Corey, they asked me to work with them on the project. So these are the prototypes of the clips. This is a prototype of a stool that we made using stainless steel connections. This is a stool you couldn't really even sit on. The wood is so soft if you sit on it, the steel clips break through the wood. This was the refined detail, which I didn't work on the design of this stuff as much. I decided to focus on the coding. But the clip is like highly detailed. It's even three-dimensional, so it can snap together. So it ended up being made out of high-density plastic, so it wouldn't break. And each clip had to be milled at the time. We couldn't 3D print this at the time. And this is as far as we got with building it. So you can see that the clips are broken on the side. So I think this is what I talk about in my contribution, is like how we learn things through making things and through making mistakes, basically. We spent tons of time on this, and this is all that we kind of had to show for it at the end of that independent study. Although what was good for me is that the software side of things, or the coding side, had been finished or developed. And so after school, I started a studio. We started doing some installation work. This is one of our first installations, and it was in a convent, group show in a convent in Greenpoint. And I think a couple of things we learned from the earlier prototypes, again, is to not use a heavy material like wood. Also, a lot of the shapes we were making were much like this, where they're kind of folded shapes, which basically fall in on themselves. So when we approached this, we decided to use a lightweight material. We also realized the form needed to be much more like fabric. So I think we were using like fabric simulation in Maya, but we weren't using terms like form-found surfaces yet. So we didn't even know what that was. It was just something where we learned through iteratively making these installations. This is the clip. It's much simpler, and it's now made of board. And then here's a version of that let's say script in Maya. So this is using Maya's history. So the clip is kind of a smart, or what we call a smart drawing. It can be changed with attributes. Here's just a section of the installation. And so there's a dialog box which has things like thickness of material and the width of the notch and things like that that you can adjust before you run it. Yeah, so you can see it generating all the flattening out all the panels, and then generating the clips. So it's just topping that clip and adding the angle between the panels. And then because Maya has this kind of, and Maya's nodal base the same way that the Grasshopper is, but it has a kind of history. So, and I think that's one of the reasons why Grasshopper was developed initially. But you can see all the clips are labeled with adjacent panels, panel to panel, and then using that history, we're just able to put everything back together again. And so those are all the panels. And like a big part of this is one, rationalizing the surface. So, figuring out the angles between panels, and also the relationship between all the panels and the clips together. So all the kind of labeling. So that's all now embedded. That's all basically embedded in a set of, I guess, tool pathing for a laser cutter. And that was like a bit over 1,400 lines. I mean, this is very different now. This can be done in Grasshopper in less than a day. But this was kind of the proof of concept for that, which I wasn't able to do in school. And then here's just laser cutting clips. And back then, I feel like we're a bit more organized now, but these are types of drawings we brought to the site. And the paper is covered in black soot and laser cutter. And then these are the clips. So at the end of the day, the development of the drawings is automated, which makes that process go super fast. I mean, it couldn't have been done without something that was automated. And that's what we were really interested in at the time. It would have just taken forever, and there would be human error embedded in that process. But we still end up with a kind of giant 3D jigsaw puzzle. And then we were really interested in conditions like this. This is just carried from the office, where we thought it was quite funny that even though the process is so precise, she's having to cut off the nubs of some of the clips because they intersect one another. And then, of course, on site, and I think those discussions at Columbia, we're using really big words like precision, mass customization, things like that. But it was all like, let's say, renderings. But when it came down to the site, the level of precision we were using was like to the nearest pizza box in terms of like holding this thing up. We were very ill prepared. It was a bunch of artists, so we grabbed everything we could to prop this thing up, which apparently is a sideways desk and a chair. So yeah, we're laser cutting things, but then we end up on site like this. And this is a photo of the final installation on site, and it was an exciting project for us because I think this was one of our first installations, and it really kind of kicked off the later work that we did in the studio. And this is kind of where I guess my contribution to the book starts. But I think most of what I've shown is like both a reactionary approach to, let's say, this type of work, but also a kind of learning through making mistakes and improvising. So, yeah, sorry. So I said thanks. Yeah.
All right. So my name is Shelby Doyle. I'm an associate professor at Iowa State University, and I wanted to say thanks to Galo and Zach for putting the event together and for the opportunity to contribute to the book. My chapter is titled A Carrier Bag of Tools for Computational Feminism, and it shares the origin story of the lab that I co-founded at Iowa State University, the Computation and Construction Lab, and the ideas that underpin the work that we do. So the lab is located on the former sound stages of Iowa Public Radio and Television in the Communications Building. And when I started in 2016, it mostly looked like this. It was primarily studio space. And so if you fast forward to now, there's a whole other presentation we could do about the logistics of this. But we have about 5,000 square feet of space and $1 million of equipment that have been onboarded in that time. And so like many digital fabrication labs, the CCL is a physical space that houses machines and robotics. But it also, I think, what's more interesting, or at least interesting to me, is that it's a home to pedagogical experiments, fabricated objects, and theoretical ambitions organized around the idea of what I term computational feminism. And the title of the chapter references Ursula Le Guin and Elizabeth Fisher's carrier bag theory, which posits that the earliest cultural invention must have been some sort of container, such as a bag to hold gathered food or a sling to carry children, rather than a weapon of hunting or war, which are common assumptions in evolutionary and technological narratives. And in a more recent piece, which is titled A Rant About Technology, and I feel like that's like a career goal to get to just rant about technology. But Le Guin writes that the carrier bag theory created space for humanity and everyday innovations in her writing, rather than only space for the hard sciences. And I like this definition because it's expansive in its inclusion of human ingenuity across scales and beyond machines. And so she goes on to say that about technology is what we all can learn. That's the neat thing about technologies. They're what we can learn to do. And I think that this was very different than the way technology had been taught to me, and that there are a lot of sort of very macho digital fabrication and computation spaces in architecture. And when you're working in a technical field, there's a certain demand of bringing data to everything that you're doing. Oh, I don't know why those numbers are not showing up. And so when I started the lab, I was trying to figure out, how do you not replicate those exclusions when you have an opportunity to do something from scratch? And so there was a certain demand to kind of bring data into that to say, is there a gender exclusion in this space, and can you actually prove it? Like, you could go to dinner and you could talk to people and they would share anecdotes, but there was a certain expectation that you would somehow provide evidence of exclusion. And I think that's a hard thing to do. And so I started to try to do that and to look at, licensed architects, computer scientists, construction workers, mechanical engineers, or however you wanted to kind of break down digital fabrication's inputs, and to say, there seems to be an exclusion occurring here, and it's not getting particularly better, at least in my career. So is there a way that I could participate in not perpetuating that? And so I went to the Cohen and Galo database, which, if you're not familiar with, houses about 14,000 paper abstracts around computational design and digital fabrication, and queried feminism. And I returned only one hit, which had been published in 1995. And so this was in 2017. And so in response to that, my colleagues and I attempted to develop a term to create space for these ideas, which we termed computational feminism. It's a transdisciplinary field which grew out of the first 25 years of the digital turn, and it continues to develop new theories of how politics of gender and other identity markers are interconnected to resulting processes of technical change and the power relations of the globalized material world. And it's a descendant of the 1990s discourses of techno-feminism and cyber-feminism that emerged in relationship to development of network conditions and theories in architecture and urbanism. And so we presented this in 2017 at the Acadia conference hosted at MIT. And so I redid the search a couple of days ago, and we're up to 6 papers, but I co-wrote 2 of them, and Banaz Farahi co-wrote 3 of them. So I don't know that that really talks about like a huge shift, but I do think it introduces the idea of feminism as content beyond representation, and whether or not that is something that remains in the field. And I think also, as I started to develop a lab, I thought it was a pretty low hanging fruit. Like, I thought, like attempting to try to create gender equity in architecture would seem pretty non-controversial, but you'd be surprised how that plays out and how much resistance there is to the idea that there is a culture to technical space. And in surprising ways, both around language and even when you're trying to define something, to say that the data that I'm showing in some ways replicates even the existence of a gender binary, but also that it somehow can be deemed irrelevant to these spaces. And so what I had decided that what remains is to operate relentlessly upon the cultures of architecture and computation using their disciplinary tools. And so the lab does a lot of different types of work. We build things through design build projects with nonprofits and small towns, typically around material and craft. We do a lot of work in clay. This is actually a collection that was developed. There were 80 vases developed for the installation of the first female president at Iowa State University. with a team of 4 collaborators. And that clay work was actually a transition into the robotics work and then our large-scale additive manufacturing work. And there's a book coming out soon called Clay and Architecture, Making Material and Machine Kin, around Donna Haraway's notions of Odkin. Other projects include writing about equity in pedagogy and ideas of not replicating structures of exclusion, running workshops where we were introducing robotics through painting and drawing as a way to kind of make them less intimidating, writing in IJAC, the International Journal of Architectural Computing, regarding authorship and the ways in which authorship is blurred in AI and in machines, and where does human authorship and labor really, I think, is maybe a better way to think about it. Of an attribution, like, is there a provenance to some of this work, and does the blurring of provenance actually allow us to share collective authorship a little bit better? The other thing that we've been doing has been writing around histories, or trying to create citations. This is a paper on the SON computer group, and then this was just open sourced on mass context, if that's something that you're interested in. And then other things like this essay where we're looking at called Women's Work, Attributing Future Histories to Digital and Architecture, reflects on the histories of the future will be written from the records we keep today, and the ways in which digital fabrication can provide a record of its creation, but that also opens us up to uniquely digital ways to track, cite, and source people and materials. And another essay, Fabricating Architecture, Digital Craft as Feminist Practices in Avery, and was questioning why we rely so heavily on narratives of biomimicry, robotics, and science at the expense of domestic traditions, such as filament winding, weaving, and ceramics, which is often considered domestic work. And then this culminated in a course, which is open source. If you're interested in any of the assignments or in the bibliography, it's available online. And I think of this as like a very small contribution to some sort of future archive. I like this quote by Benjamin Bratton, where he talks about an archive as a promise to the future that the present will make itself accountable. And what does that mean, given that we have so many histories that don't exist and archives that don't exist, and that there are so many stories that don't make it into the archival practices that are now being reperformed through this obsession with text to image and artificial intelligence. And so I was interviewed by Cornell Tech and spoke a little bit about this, but that I really do think that AI and the way that architects are using it is an archival project. And so this started with me trying to create images that were asking what a computational feminism in architecture might look like. And what you get is you get a lot of pink swoopy things, because the way that images were coded is you have pink things that were also coded as feminist. And so if you try to call up from the text image database, you're getting a lot of pink stuff. And then that imagery is also coded as pink. So I've sort of recursively created the problem over and over again. And so that's been part of a grant with the Canadian Centre for Architecture called Verbatim Archives, Access, and Other Digital Myths, and an exhibition recently at the University of Tennessee, Knoxville, where Marshall is. So this is some of the imagery that you get when you ask Midjourney to imagine a computational feminist future for architecture. And then this work is summarized in an interview for Gradient, which is University of Michigan's journal, if you're interested. So a lot of this is trying to just throw references out that these are things that people are interested in. And that's what I got.
So what?
Thanks. All right. Thank you, Zach and Gallo, for the invitation to come speak at this event. I'm excited to be included in the book, as well as part of the symposium that started it all here. My contribution to the book was an interview with Zach, I won't rehash the conversation, but I'll revisit some of the key ideas that we discussed. My work includes integrative design processes that involve computational design, simulation, analysis, digital fabrication, and this stands at the kind of convergence of many different disciplines and expertise, from computer science, structural engineering, but also biology and other natural sciences. Nature offers a world of performative principles that can be applied to design, architecture, and manufacturing. Through investigations in biological principles, we can distill out alternative strategies for arranging materials, structure, and form. And this can lead to more efficient architectural systems that use less material, are adaptive to a range of architectural constraints, and create little to no waste. So what we found that was in nature mostly uses fibrous materials to build complex structural forms, and that these are quite similar to our technical composite materials such as glass or carbon fiber. And so I began exploring composite filament winding processes, which are fast and efficient, allowing us to control structural performance at the material level. This starts from an origin story at my work at the Institute of Computational Design in Stuttgart. And we tested ideas of geometric complexity and structural topologies, robotic fabrication processes through several pavilion-scale demonstrators there. But the one I want to talk about a bit more was the UTK filament tower, which makes up a large portion of the contribution in our conversation. And I completed this several years ago at the University of Tennessee. For this, I wanted to explore sort of a tower topology, one that we haven't investigated prior to this, which are quite iconic in Columbus, Indiana, where the exhibition was installed. And we looked into the skeleton of a chala cactus as a sort of biological specimen to understand things like the directionality of fibers in the structure, or the continual sort of biaxial lattice system that form in the skeleton. So this provided some interesting insight into how you might build a lattice-like structure. Typically, you might do that through a series of standard components with complex nodes, right, making up the complexity of that structure. And this, if you look at this sort of example, would lead to 17 different components with non-planar joints, and the complexity sort of happens in that joining system, and also a sort of discontinual material over that joint. And so by looking at the biological role model, we can sort of shift that way of thinking to create, in the case that we propose, non-uniform components, but allowed for planar connections between them and continuous material over the joint of the lattice. And so this would only be possible if we didn't rely on standardization or serialized production, and could make these not multinodal composite components. And so we started through this computational design sequence where we were developing simulations for the geometry of the tower, simulating how the materials would wind around each component, structural simulations that we could use to determine where the material needed to be placed along the structure. And this resulted in a 30-foot tower structure made out of components with a glass body core and carbon fiber reinforcing on the outside. The tower was open in the middle, much like the skeleton was, and so visitors to this installation could go inside it, look up through the crown, or sit down on these base benches. These were additively manufactured to be kind of the heavy ballast of the tower. Otherwise, the rest of the relatively light. These base components were manufactured in collaboration with Oak Ridge National Laboratory in their manufacturing demonstration facility. They have some of the largest equipment in the world, and they R-sized elements for these benches that were base. The fiber composite components were made in the UTK Fab Lab in our robotic fabrication setup. And this was sort of arranged into a rotisserie-like configuration where we could make a reconfigurable winding frame and then wind the composite material on that. The frame was made out of off-the-shelf parts and could be assembled using the precision of the robot to a wide number of geometries. And then these could be adaptively wound using our robotic processes. So this was a quite messy process because it was a wet winding of carbon and glass fibers, but it would then sort of negotiate like a solid structure. And shown here at a much faster sort of pace, becomes quite repetitive, but only through this adaptive robotic process could we make the precision to put these components together. In total, we had 27 components, all made through the same sort of adaptive process, but none of them were identical. And then the three 3D printed bases that we took up to Columbus and installed with a group of my students with little to no large-scale machinery. Fairly lightweight, even though some of them are taller than us. They ranged in weight from 3 pounds to 30 pounds, and so we assembled on an on-site condition. It had an amazing backdrop of North Christian Church. And the tower had this unique material presence where it would kind of attract visitors to the site. At night, it would be lit from the inside, and so the glass fiber would basically serve as an optic fiber glow, highlighting the carbon fiber, which was the structure reinforcing into that silhouette at night, creating a pretty dramatic effect. So the experience from day to night was quite different, and we were hoping that it could serve as a beacon for this event in Columbus. This research presented here explores a range of robotic material processes for the fabrication of a lightweight composite structure. And I think it sort of exemplifies the theme of homing the machine, as well as it's a constant search for the machine interface and partnership that we had while finding the origins and applicability for new processes and design.
All right, so I'd like to invite the speakers back up. We will have our discussion, and I think we have time probably to open up to the audience at some point towards the end, in case anyone has any burning questions. So I want to. First, I want to maybe apologize because I'm gonna ask a question that we did not share with you in advance. So if I peel back the curtain a little bit, we sent some like questions, and I'm not intentionally trying to throw you a curveball, but in seeing all your presentations, I realized we might have jumped the gun a little bit in this conversation, because there are many people here probably that don't even know what digital fabrication is. So that's kind of my question, and I ask it, and I'll offer some possible answers as well. But I ask it in part because, for part of I think what makes it challenging to locate digital fabrication is that it's challenging to locate architecture at times, and architects kind of savor that sort of nebulousness of our discipline, right? We pride ourselves as generalists who are kind of just lurking and moving in between different disciplines all the time. And so I see digital fabrication kind of becoming that sort of nebulous thing in a way, perhaps because it rests on the sort of architectural foundation, the sort of murky architectural foundation or ill-defined architectural foundation. And I might also add, this is for my students in the back. This is a question I ask all my students who take my intro course. What is digital fabrication? So I'm asking for their sake also. So for architecture, I mean, or for digital fabrication rather, I mean, I think for those that are involved in this research, it's probably most often thought of as a technology. For us involved in it, it's more practice. At times in the book, it's referred to as a sub-discipline of architecture, which is part of the nebulousness, I think, if you categorize it that way. And so I guess you can answer however you want. If you want to answer in a technical manner and not a conceptual manner, that would greatly benefit my students. But yeah, I guess what is digital fabrication in your minds?
I won't answer that question, but I do want to add to the conversation that you started. I don't think digital fabrication adds to the nebulousness of architecture. I think it actually shifts the focus away from the generalist. Like I think we that are in the sort of technological realm of architecture often become specialists in that specific area of the field. And so I think or at least for me, it has shifted the way I work as an architect from a generalist to a collaborative specialist. And so, and I think architects have always sort of done that in some way, that when we make a building, we don't build it by ourselves. We're not the master craftsman. We're always working with engineers. We're working with manufacturers. We're working with construction crews. We're working with different sort of disciplines. And I think the development of a lot of these technologies have just pushed that even further, where we're almost collaborative teams that are specializing in things together. So that for me has taken digital fabrication not as a definition, but in a different direction about architecture.
Yeah, I think in the realm of architecture, it's interesting. The architects don't simply build buildings. And I think lately are more super interesting. Yeah, there's tons of digital tools in order to manage all the processes, etc. But I think this idea of specialization is something that, we're in much deal. We're constantly trying to push back against the idea that you could become beholden to a technique and things like that. And so, and also it is a collaborative process. So I think if you walk in any shop, whatever the case may be, it's highly specific acronyms that are going around, and that's something, at least in our office, like if anyone starts doing that, I push back against that. Ultimately, we're trying to open up possibilities of what we can produce. Right? So those things to me, again, like, I mean, the projects I showed, yeah, we were like overly different. They're probably really annoying at that time. We just wanted to produce a complex service in an economic way at that time. So that's pretty easy to do now, and even then, they like, okay, what the heck? We did it, we're effective. So I think for us, it's always been about leveraging those tools. I guess I'm not really defining it either, but leveraging those tools to make something more like economic, like something we can do that's more that maybe we couldn't do last year, we couldn't do before, and now. I think our clients don't really understand or see it this way, but we're many times giving them something that, that built. How we love less.
I mean, I guess I don't know if your evasiveness is because I'm catching you off guard, or because the nebulousness is potentially helpful in the practice, or because it is, after all, an emergent kind of field, and so it's still in the process of kind of defining itself. But I guess part of this book is taking a moment to look back on what's been done in the past couple decades or so and say, well, is there a definition or are there many definitions? And then how do we think critically about those and move forward with that? Um, after that reflection, what do we move forward with? I guess another way, another interest of the book and another way to frame the question is, what is the value of digital fabrication and architecture in your mind? If I understand Marshall's answer, it's the opportunity to collaborate across disciplines, and to have essentially another form of communication, which is a technological form of communication, communicate through the machines in a sense, through the technologies. And Mike, I understand your answer to mean that the value is the kind of innovation of techniques, primarily, and the sort of design freedom that those techniques essentially allow you, right? Correct me if I'm misinterpreting, but like that's kind of what I get.
Yeah. I think when I was younger, it was like I just wanted to increase the bag of tricks so that if anything came up that we weren't limited if we sat down in the conversation when we had an idea about something. We weren't limited by what, but I guess represent even, much less still. So yeah, that's why even now, that's why we don't. But the flip side is we don't want.
I guess I'll not answer your question as well. Is that I replaced digital fabrication with computation and construction in the work that I was doing, because I think that there's a sense, and everyone's heard some sort of version of this joke, that when you're working in digital fabrication, someone is like, "Oh, just have the robot do it for you," and you're like, "Have you met the robot? The robot is not like doing anything that I'm asking it to do." And that by talking about it in the relationship of computation and construction, I think it also tries to take seriously the labor of architecture and materials and extraction and disposal, and that like so much of this work involves like pushing carts and hauling trash and all of these things that get kind of edited out with the GoPro videos, where everything's like very sexy and entire project happened in 60 seconds and nothing was sticky. And like that sometimes when we refer to things as digital, they somehow become they no longer have to deal with any of that. Like, there's.
I do think a lot of those things. Those are my favorite parts. But everyone edits those things out.
Because it's
maybe prove that that's something that do.
It's like, oh, we solved it. It was efficient and optimized, and then
What's the value of that?
Well, we could talk a lot about architectural academia if we wanted to.
No, but I'm just saying, like, that was to me what, like, this idea of like we solved. We're architects, we're selling things really expensive, but that's why I wonder why, like, that's also part of all this work that we thought. What I guess for us, we're like, I think that's what I'm saying. Like, it just great. It's like the invention of the ship like we're just producing that stuff. Or for us, that's good because then we have something to move forward with stuff. But I do find it like interesting as soon as you move into like that digital art. But the messiness needs.
I think I get the language that we were talking about, though, about when I was introduced to computation and digital fabrication, the language was around efficiency and control, and that there was some sort of notion that you were going to like dominate everything, and that really led the conversation. So of course you weren't going to show anything that was like awkward or messy. It was like, no, I made everything do exactly what I want.
But I think I want to pick up on that idea of success, because I think that's the kind of metric that a lot of digital fabrication work and research revolves around, right? Like you have to have solved the problem. And when you show your approach to the problem, you edit out the messiness, right? And so maybe instead of talking about success, we did give you guys a question about failure. So maybe we can talk a little bit about, well, what is a failure or a failed digital fabrication project, or maybe your position on failure, not necessarily as the messiness or the the roads not taken in a specific problem solving, but maybe failure as something that's counter to the expectations of what you do, or maybe the expectations that are set by those that set the rules for digital fabrication. You know what I mean? Like, what is failure to you in terms in this realm?
Well, I might answer that in two different ways. One, digital fabrication could be seen as a failure in certain ways, but it also could be seen as the metric or filter in which you understand failure. Especially with respect to design, full architecture, like the development of the digital tools that lead to computational form are sometimes filtered through fabrication, like fabricability or what can be built, what can't be built, right? So there's a sort of metric at looking at anything and everything that we can draw and model as what we can. Right. So I think digital fabrication can be used as a way of determining failure success. I think the other way of thinking of success or failure is the application of technology, and we talk about this in our conversation in the book, where sometimes, especially in an academic setting, a goal of ours is to sort of apply technology. That's right. What it can do, what its role in a project can be, to see what sort of novel steps can develop that. Sometimes that leads to unnecessary uses of technology, and so there's a failure that can be evaluated through that process of if that was even a necessary step. Can't do that from the beginning. You don't know if it's a necessary step until you get that process failure or not. And I think a lot of times through some of the work that I've done, I can test where that threshold is. Do I need this technology to accomplish the goal? Is it a sort of stand-in for something that might happen in the future that maybe is more applicable? And those questions start to arise at success or failure of that.
I guess, like, when we talk about most of this, or with architecture, digital fabrication technology, I think so much of it is more about the value proposition of what you say it is. And if you say digital fabrication is creating like hyper smooth, effective, optimized processes, then that is what success looks like. And at least but I guess what I was trying to say, and it's hard to take 10 years of work and make it into a 7-minute presentation that's at all cogent, but that the technology is the cultural practice. It isn't the machines and it isn't the software. It is like how we decide technology. We are the technology in many ways. Like having just like the machines are in many ways irrelevant because they just sit there when we're not there. And I mean, you've even written about the idea that you sort of sit next to them while they're printing and are like, please don't. And that weird thing that happens when you're like not really touching something, but you're somehow making it. And that I think like it's really in many ways not about architecture or about digital fabrication, but it's really about how are we creating ways of interacting with one another through materials, through these forms of technology, than it is about digital fabrication. And I think that's what's a harder thing to move. In many ways, it's easy to teach someone how to do different. It's much harder to say, like, there's a series of values around labor and inclusion and co-authorship and collectivity, because those are way more nebulous, and it's a lot easier to write code, frankly.
But I mean, and not to call it, well, I don't mean to call you out on this, but I will. But part of what's in your contribution is the kind of necessary duality of the story you tell, right? So you're telling one story right now, which is the story about the cultural practice, but you tell a different story to your funding partners, to your STEM institution that you're part of,
Absolutely.
right?
don't.
For them,
Yeah,
success is a very different thing. So like, so you need to present both. And I don't know. I mean, does that mean, I guess, which one do you believe? Or, you know, do you have to convince yourself of the other one in order to sell it?
I know what I believe, and I know the environment I work in. Like, I'm in a deeply red state where diversity, equity, inclusion has been canceled, like effectively canceled. I could not right now go into the university and say, I want a grant to generate a more inclusive state. I can't use those words. So I have to come up with a bunch of proxies and ways to sort of fictionalize fact and data to not say that, but to continue to generate those spaces. And one of the ways you can do that is you can pretend that STEM is some sort of neutral space and be like, oh, we're just engineering. We're just using robots. And then you can like slide in the social project, but you just can't say that's why I've heard out loud. You know, and so, I mean, I don't know what that means as like navigating institutions which are designed to effectively exclude and then try to in some way produce some sort of inclusion through them is kind of a problematic practice in of itself. But I also know, given what happened on Tuesday and the world that we live in, that it isn't a guaranteed upward trajectory of progress towards some sort of, and so it has to be something that you say over and over and over again, even when it makes people deeply uncomfortable. And sometimes you have to use other words.
And I think what you're describing actually is a process of calibration. Like, I mean, I like this idea of us actually being the technology. We were the technology all along, right?
We've always been the technology,
right? And so we were the digital fabrication machines, and so the idea that we have to self-calibrate in various contexts is kind of interesting because does that mean that we can actually learn through the various like nuances of our engagement with this technology, that we learn something more about social dynamics, and we learn more about how to calibrate our own values and how to sort of collaborate with different actors? So I guess what I'm trying to get at is, what have you learned through your engagement with technology that maybe is not necessarily a technical thing, but the technology has taught you something else? Has it taught you anything else other than technical prowess?
Yeah, I mean, I think it goes back to that question of like, everything is about something being fast and new, and, you know, the move fast and break things ethos that's like technology at any cost. You're going to get very specific outcomes. And if you are, to your point of success, if you're willing to set up a different set of outcomes and a different set of preferences and values, you might get a different result. And I think that's what I've learned, in that if you just throw a bunch of robots in a room, even if I'm teaching, I will get an all-male class if I don't go out and facilitate a culture that says you all could be roboticists. And that, I think, was the biggest thing that I learned, was that you can't just bring machines into a space and say everyone can use them. It's like you actually have to create a culture around that equipment and around that work that says people belong there, and that they're not going to self-edit because of years of sort of indoctrination.
Yeah, I mean, especially when we started the studio, everyone called it digital design studio. That always annoyed me. I mean, I think there's a like kind of clubbiness that always happens. Like if I would visit a school, whoever's showing me around takes me to see their new industrial robot, right away. And like, they just assume that I want to see that. And I mean, I know it'd be shocking them, like, what's going on in the design studio? That would be strange. Yeah.
We asked to see a robot.
But I think, this is like, constantly gets reinforced. And I mean, like, I don't have an innate interest in a robot at all. I mean, I'm super interested when I see something that I think is novel done. I don't really care to see, but that happens. It's like a kind of hot rodding. I mean, it happens all the time. And like, I think, but we all do that. That's why we produce those conditions. I mean, I think, I don't know. It's like, it is the shiny new thing. I guess I wonder, is I mean, there's like academic practice, there's like a lot of different things, but as a design studio, right? Like if, you know, and we've seen it time and time again. I mean, if you stake your claim on a technique, I mean, that was like what was good about, you know, going to Columbia at the time that I did. I mean, there were people who named their studio on the new Maya tool that just came out, right? I mean, it seems so, I mean, I was naive. That seemed really naive. But I think, like, if you stake your claim on technique, unless it's something really special, or you become the person who's pulling that term, it's going to be very difficult to, you know, whatever, get commission new work, etc. So is there, I would always turn it around. Is there something about design practice, like traditional design practice, on the term, like something, everything that is not a digital practice, that might, you know, recalibrate, like, what we're calling digital fabrication, etc. Like, I mean, if digital fabrication is so essential, how do regular design studios survive that don't use stuff? Right? And maybe there's a, you know, there's a formula there. Maybe error is much more, failure, let's say, much more important. I don't know. I mean, obviously there's a huge technical design studio, but I think that's how we think about it. Like in the office per se, we're definitely invested in some of these tools, but design's also a part of what we do. And so, I mean, I've been around long enough that, like, I know if we go talk to a client about, like, hey, this is a new shiny tool, yeah, that will resonate. Yeah. But I think it's much more interesting when we bring both of those things to the table. And I think, honestly, yeah, there's certain, like, there's schizophrenia of, like, if you're trying to get a grant or start money, you're not going to say, I mean, you're not going to show, like, failure. Of course, we don't want a catastrophic failure to happen. But I think clients respond in a certain way to showing them, hey, if we're doing something new, you have to be on board with that. But we don't show them not rendering. We also leave a couple things unknown, because if it is a challenging project or something new, like, they need to be on board. I think on images that say, hey, there's something new here. And so you just reframe it. The value system becomes, hey, it's the new view. I guess
I mean, I want to pick up on, so you brought up questions of practice, architectural practice, and technology's relationship to practice. And Mike, you have a very unique practice. I think, I mean, honestly, maybe there's 3 or 4 practices and that I know of that are like yours. But I guess my question is more towards called traditional design practice, and what do you all view as the relationship of digital fabrication to traditional design, and more specifically maybe traditional design, build, or construction practice. You know, where is, like, how, you know, I mean, I think I have my own answer to this, but in your minds, how far out is digital fabrication from actually integrating into traditional construction and design practice? Or do you think that will never happen and its purpose is better served elsewhere outside of that kind of practice?
I mean, I think there's tons of digital fabrication happening in construction, especially if you go out into light industrial. I mean, like, they have robots all over. Like, the EFCO is like one of the format work manufacturers in Iowa, and they have like an army of robots welding really standard formwork. You know, I mean, I think in many ways it's like a much easier sell on the construction side than in like the sort of office environment. But that's also because legally architecture gave up the plot on being responsible for construction. Like, I don't know what year the AIA 201 came out, but it's like, we were like, oh, we don't do means and methods. So I think in some ways it doesn't belong in an office, because you're not building things when you're like actually there. So it's like, unless we're going to actually change the contractual relationships that we've ceded to contractors, I don't know why it would return to traditional practice, in the sense that, like, if you are legally responsible for making a representation of a building and not the building itself, like, why would you?
I mean, I do think there's like an implicit relationship to traditional practice that with technology, right? With every development in technology, there's an equal sort of development in that has maybe infiltrated practice in ways that we aesthetically forms that we create are driven by the have the forms that we make, the materials and methods that we have of construction. Those sort of demonstrate tools and designs that we see that are put out. And so the aesthetics that are recalibrating, what architecture is now are totally different by art. So it's fabrication. And so I think those are things that we're learning, that are embedding themselves in practice, and changing the way we see.
There are on the flip side, you have offices that are like, oh, we don't do that, and it's like, I mean, that's also interesting. Have we made our own? Have we given this, whatever this is, this digital workflow such a bad name that certain offices are like, oh, we're not doing that. Even students. I mean, even students are like, you're making this curvy building. That's gonna be hard for you. Just, and you ask them, hey, what could be better like this? Do the handrail. I'm not doing it again. Well, why don't you open Grasshopper and try? That's like the easiest thing. Then you have like, entry point into that. It's like, I'm not doing it like that. So that's all. I mean, that's the flip side, which is there are people who are just totally using these things for like banal things. That I think part of it is, maybe there's an aesthetic associated with that. Like, that's also the flip side.
Maybe we can open it up for audience questions, because I think that's a nice segue into students' perspectives. Did you get that right? Or maybe even just general public perspective, right? Because again, digital fabrication is a pretty niche phrase that we throw around in architecture. But I mean, if anybody has any questions, we'll be happy to answer.
So much for your presentations. It was really amazing. Congrats on the book. I had a question about homing, and maybe the idea of homing not as solving a problem necessarily, but wayfinding, or finding your way through something that maybe you don't know the endpoint of. So I was just curious if you have any responses to wayfinding in your practice.
Yeah, I mean, I guess, my contribution to that, which I think came up from, I mean, this wasn't something I was thinking about back at the office, how it has been the problems and the messiness and the errors that were the most productive. I mean, not the most productive, they have been productive for us. So we didn't necessarily plan those. And I mean, that's what I try to show with some of the things that I did while at school. And I think we're at a stage now that we didn't know back then, like, what about things now back at the office. It's like those errors were really productive, but it's almost like that self-therapy. So do we try to produce this? Do produce this? Does that circumnavigate the value of those things? So I think it's much more like, if you mentioned homing, like how do you home, let's say, if you were to use an analogy, a machine where the home is constantly moving around. And so I think and I don't, again, I mean, for the solution problem, I don't know if we ever really want to get, I mean, we always like this kind of radical democracy. We're trying to solve problems, kind of flop. And I believe those are new territory, but we're not trying to find, like, we're not actually trying to find best.
It's interesting thinking of like a machine homing itself, like use the CNC machine as an example of how it finds its origin. I was trying to think of an analogy of how I sort of design or how it relates to that. And I'm thinking of like the multiple sort of motors that all sort of pull together to find that one sort of position, right? They're they're pulling in their own direction, but collectively sort of moves the machine. And I can draw some relationship in this conversation to design for how the many different forces in the design process that uses digital technologies and fabrication and other sort of integrative processes that I've mentioned might drive the design process or find their way through that design process, where you might not know an endpoint that you're getting to, but each individual thing sort of pulls in a direction that finds where that is. And that's a good analogy for me in this sort of conversation, because I often don't have that end goal in mind at the beginning. I just know the constraints that I'm putting on process. I know that there's certain limitations to materials, certain limitations to structure, certain ideas and principles coming from biology, that there's certain like constraints of the tool itself that limit the design in different ways. And so all of those things are pulling on a design process or pushing it whichever way you want to go towards the home, towards the place that all of these things, find their that create, right? So that's a way of wayfinding. That's a way of like finding that home position that all of
I think in the book, Theodora Barduli writes a really nice piece about kind of this idea of seeking home. And also, to stretch an idea in that we think of home as somewhere kind of welcoming or as an origin story. It's both a destination and a beginning. And that when we tell stories about technology that assume that there's some sort of singular narrative and that origin is the only narrative. And that, when we think of the tools that we use and when we think about robotics, we think about CNC, we think about 3D printing, the internet, these are tools that came out of the U.S. and, industrial war complex. Like we are repurposing things that were generated through military funding and we're doing other things with it. And that's a very specific way to kind of think about technology in a very specific moment to inherit technology. And so part of the writing the chapter and the other work was to say, what if there is some other origin, some other home that is more generous or more capacious or more welcoming than the home that has been for so long part of this narrative and so embedded in the logic of the way that computation is deployed through material.
Thank you, everybody. Super fascinating conversation. So it's great to hear. And yeah, I'm going to home in on the homing too. But another analogy here just is that when things go off the rails, when things fail, when things start to mess up, the machine homes itself. And maybe in some way, and I'm looking forward to getting into the book, that this desire for a critical practice of digital architecture, a critical digital fabrication, is there something that has gone wrong? I think Shelby has pointed to some pretty clear examples of things that have gone wrong. And if so, since you are all teachers, is there also a way in which the pedagogy of teaching digital fabrication is in a state right now where it needs to find a new home or needs to rehome itself or find another way in which it is brought into curriculum? Because the way that it was brought in at least 20 years ago, 15 years ago, was as the special thing, the added elective. And then it became part of representational sequences as, let's say, the expanded tool set. But this is like super open conversation. What I really want to know is, since you guys are all involved in teaching this right now, what are the ways you're thinking about rehoming the pedagogy of digital fabrication within design school? Big question, I know, but
I think it goes back to what we were talking about, where you're operating in an institution that demands that you create pedagogy and then evaluate students as individuals. And so much of like the ethos of working in digital fabrication, where you're using hardware and software and stuff that somebody else made, undoes that idea that you're somehow some solo actor in the world. Like you can't, like, if you're using Rhino, if you're using Grasshopper, if you're using a CNC, if you're using a 3D printer, like you are kind of collaborating with all of these different people that make the work possible. Like the idea that you're just sort of sitting there as a genius and like ideas are springing from your brain is no longer available, even as a fiction. And I think as a teacher, it's very hard to, if you're still working in a system that wants everything to kind of be individualized and evaluated, that you have to do a lot of work to resist that and to create assignments and projects and narratives and citations that don't reward kind of that individualistic approach to design. And I wish that we could really, I mean, I think sometimes like just to rethink all of it every day. But I think also to the point when you show up and you have to say to somebody, like, what do I value as a teacher? You have to do a really good job of laying that out and making a class that rewards the behaviors and ideas that are valuable and doesn't necessarily say, like, that GoPro video when you know exactly what I'm talking about. We've all done it. We all have that GoPro video where you're like, there's 3 weeks of work, but it's a 60-second video.
Yeah, I mean, I don't know. I mean, I think I think like to me, like when I was in school, being back, there was no, there wasn't that. I guess now, like you know, this thing arrived and or someone showed you a post smart table. I mean, that smart table looked so boring. I mean, it wasn't even curved. And now it comes with all those things already, you know. And I think, like I teach a computation seminar at Yale, and I teach it the past couple of years. I'm teaching at CCAM, Center for Collaborative Arts and Media, which is a place with like all these scanners and all these things. And so the hope was to move it into that school, which is right across the street from Rudolph Hall, but like the students would enjoy getting out of the building, etc. There's all these things there, and it's new to them. And the class has gone way worse in that building. You know, students more and more now, you know, and I get it. I mean, people want jobs and things like that, but it is much more the sufficiency. Like someone's like, okay, can you show me how to write software where it tells me where to put the building on the site in the most efficient place? And it's like, to me, there's like, it's now a technical class. I mean, there's no, let's say, there's no curiosity about it being a design tool, you know, or a place that maybe not errors or failure, but discover things that you didn't think possible, et cetera. And that's, I mean, maybe from the fact that like college or, I mean, when I went to schools before, like Web 2.0, all these things where it's just like now we're inundated with like every piece of technology, the opportunity to HC money to do all like that wasn't going on when I was in school. So I know that all plays a part, but I think, yeah, I mean, there's no idiosyncrasy, no part of it. So now I'm saying what I see. I don't know how it changes in the school, but you know, like I think maybe rewrapping these things so they aren't about, and I think it's hard. Like it's not about getting a job. Leave the tech still with that part. I mean, I guess we teach work to help people get jobs.
True. I'll add to that a little bit. I think there's a planned obsolescence. Technology inherently is updating fast, and so it's the teaching of the technology is necessary, but also somewhat. And so, in terms of a pedagogical model, I wonder if a sort of computational a skill set is not a more necessary thing, right? That the tools that students might be learning in school right now are probably going to be different as they get out, but the skill set to be able to adapt to the new tools, the new processes that are there, are something that students might, know that software, but don't know that. So I think that's a sort of way of reforming the pedagogy to make full aspect of that. And a sort of agnostic technological approach, computational design, like a way of way.
I think for me, and this will resonate with those of my students that are left. But so historically, digital fabrication has been viewed as a means of production in the kind of industrial sense. But for me, it's always been production in the kind of performance sense, as that digital fabrication is an orchestration of a certain kind of performance, oftentimes a material performance, right? And it's inherently process oriented. So I find it to be a really great way to teach process, to teach how to be in process or how to be agile through a process, how to make decisions on the fly. And that is a very translatable skill that, so digital fabrication becomes like an alibi for teaching what process is. And of course, that's really important for design, right? And oftentimes we, as much as we try to hammer it into students, they don't, and they just fixate on their final production. And still, when final production comes around, or the end of the semester comes around, everyone runs to the 3D printer to produce that perfect model, right? So there's still that kind of like vestige of like, this is a technology for perfect production, for production in the industrial sense. And I think that's not where we've gone wrong. I mean, I don't fault us for introducing it to schools in that manner, but I'm personally trying to reintroduce it in the other sense of production, which is in terms of orchestration, I think, broadly speaking. And that's pedagogy that my own classes study.
I think maybe another way of saying that for me is I see digital fabrication and even sort of the culture of computational design as an ethic or an ethos, meaning that I think that there's very clear effects that have emerged over the past, like, say, 25 years of using these tools and going through these processes. And one of them that I'm really interested in is the tool making ethos, which is this idea, like Mike makes his own tools, right? And there's so much involved in just the ability of being able to make your own tool, which was completely out of grasp, like for a long time. Like these CNC mills were in labs, in bunkers at MIT or something like that, right? But now you can 3D print a 3D printer, right? And so the culture of DIY and the maker movement, I think that actually has a lot of really interesting ramifications, but that are not just technical, but also social, right? There's all of a sudden like maker zines and clubs and initiatives in Global South that bring 3D printers to people that could otherwise not have access to it. And so if you look at it as an ethos, or look at these effects as kind of not necessarily ethical in the kind of equity kind of way, but like just literally as these ideas, these almost like, I guess what used to be called ideology, right? Then actually that becomes a way of reorienting digital fabrication in a critical way, because we can talk about what does it mean to share knowledge freely versus privatizing it and selling little bits of knowledge at a time per month, right? And I think that's really a conversation that we try to bring in with the social chapters in the book, because I think that there's something really interesting about talking about just access to technology and just the whole world that was opened up when all of a sudden students and professionals could build their own tools, for example, right? Like processing, the Processing Foundation is kind of committed to making the tools for building software freely available. Grasshopper was free, right? You didn't have to pay for Grasshopper. And there's the other side, the private sector, corporate software. But for me, like the impetus of homing this discourse, or rehoming it, is to bring those issues to the practice.
Yeah, I mean, I think when we used to talk about it this way, but so far removed from that. The excitement around those tools wasn't making the surface to me. I mean, that was kind of dope. That was the way people were involved, but it was extremely exciting to say this. I mean, and it goes back to some of these tools, like this software was not made, but now I can make it how I want it to be. I mean, that was like eye-opening. And there's a huge amount of agency, and we thought of ourselves actors and all these things. But I think the question is, over the years, yeah, there's things like processing, which is open source and things like that. But a lot of those things become, not even the control of the money and who has them, but the image of how those things get deployed. Like, because now we're all looking at someone used your software and come out the way, but in the wrong, this has to flow back. So that I think is not necessarily great, but I think, I think it's maybe operating these things like Zach, you're talking about process, but it's not about like computational process isn't totally umbrella, aesthetic, tech, shop person, but it's really about this is how you have agency. If you either get a car and you can fix that car and get under the hood, or you can't. And I think like being able to do these things should be told in that way. The software and the tools are going to arrive. Do you want to cut the and I think most people would get behind.
Thanks. This is a question from somebody who has no idea what you're talking about, but also kind of does often, weirdly. My brother. Oh, I'm also Zach's brother, but that's not. I'm really curious about your relationship to philosophy and the humanities in general, because there's something really strikingly human about a lot of your interests. You're interested in messiness and failure and ethics and ways of relating to each other, and these are all questions that people in the humanities are also really interested in their knowledge creation, labor, and so I'm really curious to hear about what are some of the philosophical and critical theoretical traditions that have most nourished your thought or felt most sort of vital to you, and what are some of the movements right now that you're most excited about, sort of in the realms of critical theory, feminist philosophy. You cited Donna Haraway a lot, who sort of is a philosopher of science, but a philosopher and a feminist philosopher, and not a humanist, but interested in the body. And so, so how do you relate to philosophy and critical theory, and how has it informed your thinking in the past and in the present, if at all?
Probably badly, but mostly what I've noticed, and this is a tradition in architecture, seems to be that architecture comes to a topic. People were really into Foucault when I was in school, or Derrida, and it was like, we're going to go into a field, biology, philosophy, we're going to co-opt what's comfortable about that, we're going to bring it into architecture, and then we're going to talk about it like no one has ever thought about any of it before. And architecture loves to do that. And so as I started to be like, I actually haven't read any feminist theory, no one ever introduced me to this in my 7 years of architectural education, shockingly, people have been writing about this for a really long time outside of architecture. And architecture, despite thinking of itself as very progressive and very sort of forward-thinking, often it's very late to these topics, and in the sense that we lean on the STEM fields often, I think, because there's a clarity that the humanities does a really good job of grappling with, and that in institutions such as mine, which is the University of Science and Technology, the humanities are at risk. It is safer to dwell in a technical field than to do the messy because of the way funding structures are rewarded. So I've read everything that I have been able to find, and then have felt like I wish there were better moments educationally where we found space to talk about technology as a humanity. And that's why the AI, the abundance of mid-journey images and the readily adopting text to image is sort of so terrifying, because it is a technology that seems to be divorced from that conversation. And if it is drawing on deeply biased archive, we're just replicating that. And to the point of education, I think so much of technical education is really being able to look at a system and see what's wrong with it, rather than just their received things. And there are all sorts of fields I keep coming up against and going, man, architecture does a really bad job at this. And to your point, I mean, I think it's just that we often teach technology as skills. We say like, oh, if you learn Revit, you'll like get a job. Not like, what does it mean to like hang your entire career on a privatized software? I think like those questions of actually being able to sit and say like, what is technology to me in this field far supersede digital fabrication and are much more about the relationships that the humanity to do such, good job. For like, we could put numbers to it and then not be uncomfortable.
Yeah, we learned, I think, inadvertently again a long time ago that, I think when we did our early work, technology was front and center because that made us the coolest thing in the room. And we learned cool about what we were doing. I think, but we started to use like the project I showed where every clip was different. It was a cardboard clip, and we had to put it together. The next project we did, we put together at a similar form, but we put together completely with binder clips. And mostly because someone picked that up in the office and was like, can we use this? I mean, these are all the same. This would solve this problem. And inadvertently, and that was in a gallery in the Lower East Side, everyone who walked in that gallery saw the binder clip, and that became their way to relate to the project because it's something every day. It was nothing digital, in a way. I mean, and so in many cases they were like, oh, this is just standard office equipment. I could make this. This is stupid. And then they looked closer and realized 4,000 pieces were all labeled and all different. And then they were like, holy shit, I don't want to meet these people ever in my life. I think that project and other projects, we realized like we always are trying to figure out a way that we both combine the digital technology with something that allows the entry point into the project that isn't our peer, there are other people. And I think this is where like things like I think idiosyncrasy is highly important. So it's also hard when you're working on computational tools, random functions and things like that. But I think like years ago, Jeff Bezos in the New York Times article described they have this thing called which also has like kind of labor issues where people are doing mundane tasks which Amazon invented internally to do things like image association, things that can be done computationally now much easier, but he called it artificial intelligence. And I think that will be something that I think becomes important later on, not the kind of labor practice, but I think the idiosyncrasy of humans is like our worst quality, but will end up being the thing that everyone's asking for again, I think later on. And so I think that's where failure, like this idea of moving things forward by like finding things that you didn't foresee. And I think the amount of investment it comes to making custom tools, this was also something that we talked about. Like when we decided to invest in this, it's not invest money, time. We're looking for a street output. And that also that's the build, right?
Yeah, I think we need to wrap up. But thank you to panelists. Thank you to you all. One last order of business, since this is, after all, business for some people. Buy our book. Use this discount code. Go to that website. Use this code. Tell your friends. Take a photo and send it to everyone. Thank you again, and have a good night.
Thank you so much.